All right, so as we begin our new book today, it's in the system. Our focus for this first one, it says, how is the solution for a two-variable equation different from a one-variable equation? So if you take a look at these first three, right, you notice that these three have the same variable, right? X, okay? And what we're going to be dealing with in this one is when we have an X and a Y, okay? We can't solve when we have two variables like you can with the traditional solving an equation for X, like we've been working on. There's a different way that we're going to have to do it. We're basically going to work towards that in over the next two investigations of this book. We only do half this book. We don't do the whole thing. All right. So this is where we're going to begin today. Shut this thing off. So if you turn to page 8, we're going to read the scenario here. And our first task will be to fill in the table below that you see there in part A. So it says, the 8th graders are selling T-shirts and caps to raise money for their end-of-the-year party. The profit for the fundraiser depends on the number of caps and the number of T-shirts sold. So there you can see the chart, which we also have up here on your worksheet. You have $5 profit per T-shirt, $10 profit per cap. Again, their goal is to raise $600. So if you see, as you see the table in here, they're giving you certain things for a certain number of T-shirts and caps. So what your job is to do is those columns is to find the profit per T-shirt, the profit per cap, and then the total profit if you sold both of those. For example, so the first line, they want you to find the total profit if you sold 15 shirts and 10 caps. So that row is the same one. So we're going to give you guys about 5 minutes to work on this table just in part A. We'll come back together and see how you do. So you guys are going to team up here, all right, for about 5 minutes. So we're going to pause the video. All right, so if you sold 15 shirts, what was your profit? $75, right? Because the profit per shirt is $5, right? So if you just took 15 times 5, that's $75. Good. What about for 12 T-shirts? Let's go across. What's 10 caps? 100, right? Because you got 10 times 10. That gives you 100. So your total profit would be? Huh? Yeah, you got 75 plus 100. So you got $175 would be your total profit. Okay. So obviously that wouldn't get you to your goal, right? What's your goal? 600, right? So you're quite a ways off right now. All right, what about if you sold 12 shirts? That gives me 60. That's 12 times 5. And 20 caps. So our total profit is, right, we add them together, $260. Well, we're getting there, but we're not quite there yet, right? That's not the combo we're looking for. So what if I sold 30 T-shirts? 30 times 5 is 150. And 50 hats. $500. And 150 times 500 is $650. So that would get us to where we need to, right? So the bottom row, when they give you the variables, now we're trying to come up with an expression, right? So what would be in the box profit per T-shirt? If we sold T-shirts. 285? No. What number would have to be in front of the T? Right, T-shirts are $5 per profit, right? So 5T. Always put the number first. Which means then the cap would be what? 10C. So basically here you're coming up with an expression, right? Because to find the total profit, you take 5 times the number of T-shirts sold plus 10 times the number of caps sold. And that would give you your total profit. Right? So basically this column here that we did is the expression for all the rows up above. Okay? All right, moving on. Everyone got that? All right, so now in part B, it says identify at least 5 combinations of shirts and caps that would produce a profit of $600. So be ready to show your calculations and justify your answer. Now, obviously what we're going to put up here is just going to be a kind of a combination of everybody's, right? Because you could literally have tons of different answers for this. So here's your next task, okay? Is you and your group are going to come up with the number of shirts and caps that are going to give you at least $600, okay? So you'll fit your numbers in here, you'll figure out the profit, and make sure they're over $600. You're going to add them up here, show me your calculations, okay? Then down below, you're going to take those solutions and plot them, okay? Now, on the graph down below, if you notice, they've labeled it for you because that's very nice of them. The number of t-shirts sold is your what? What variable? X, right? And then the number of caps going up is your Y. So just kind of just so you kind of have an idea, when you go to plot these or make them into a coordinate, you at least know what is what. Okay? So this is going to take some time because obviously there's going to be some trial and error. You're going to pick a couple points that may not work. So we're going to give you at least about 15 minutes to work on this. Okay? Fill in the table. Once you fill in the table, plot your points. And you're going to be plotted as a coordinate, right? And then try to put them on the graph as best you can. Now, the graph's going to help you out just a little bit. Because does the graph go to like 400? No. So try to get combinations that are within the range of the X's and the Y's. And I think you'll find yourself to be pretty successful. All right, any questions on what you're going to do here? All right, so you guys are going to try to find 6 combinations. Okay? I'm sorry, at least 5. If you want to fill in the whole thing, great. If not, you can fill in a couple from, as we kind of get, because we're going to get combinations from every group. Okay? So, go ahead and we're going to pause this. So I'm going to go around to all the groups. Just give me one of your points here, and we'll put them all together. We'll start with you guys. Just give me one of your answers that you got to 600 or more.
20 t-shirts and 50 caps.
So 20 t-shirts and 50 caps? Okay. So 20 times 5 was 100, right? And 50 times it's 500. So we got 100 plus 500 gives you 600. And yeah, my bad, by the way. We were supposed to equal 600, by the way. All right, so give me one of your guys' solutions that got to 600. Different than this. 40-40. So this was 400, and this was what, 200? Right? All right, which gives us 600 on the button. Good. Okay. Give me one of your points. I got to 600. Third table. Any one of them. What was it? 60-30? So 60 times 5 is 300. And 30 times 10 is 300. So there's your 300, 300. Okay. All right, good. 3 good ones. All right, guys, give me one of your points. 80-20. So 80 times 5 is 400. 20 times 10 is 200. 400 plus 200 is 600. Good. $110 shirts. Oh, 100 t-shirts. And then 10 caps. So 100 times 5 is 500. 10 caps times 10 is 100. Okay, good. What'd you guys come up with? Anything? 120 t-shirts and 0 caps. Because 120 times 5 is 600, and that's obviously 0. Good, you found an intercept. Which intercept is this? Huh? It's x. Y is 0. So this one here, this is your x-intercept. That's the point along the 120 mark along the x-axis. All right, and in the back, last point. Just give me. Okay, 110. So that's what, 550? And 5 caps at 10 is 50. All right, that's all. That all works. So if this point that I circled is the x-intercept, right? And if I did this for x, that means we'd be finding the y-intercept. How many caps would we need to make 600? Anyone know? 60. So if anyone had this point? Did anyone have this one, by the way? You guys did? Okay, good. That's your y-intercept right here. Okay. So if I were to go down and plug these points in, okay, so you got 20, 50. And again, when we write them as a coordinate, right, comma with the parentheses around it, right? We got 40, 40, 60, 30, 80, 20. We got 110. Go on a little bit more here. So we had 120, 0. And again, that's our x-intercept. And then we had 110, 5. And just kind of help us out, I mean, at 0, 60 was that 1. This is where it starts, right? And at 120, 0, that's where it ends. And all those other points, just to save us some time, are in between. So I'm just going to save time, just connect the dots here. There we go. And that's what our line looks like. So the question here asks, how is the 2-variable solution different from a 1-variable solution? Well, obviously the biggest one is it has 2 variables, right? So there's 2 things we got to figure out. As you were solving up above here, you had to come up with different combinations that equaled 600, right? And there were many. Okay. Here's the biggest one also. In a 1-variable equation has 1 solution. 2-variable equations have many solutions. Now the other question we've talked about this already this year. Why doesn't the graph include quadrants 2 through 4? So why don't you see anything over here, down here, or even over here? Why are those missing? Yeah, you can't have a negative number of t-shirts or a negative number of caps, right? That doesn't make any sense. So those quadrants over there don't make sense to our situation. So there's no point in including the entire graph when this is the only bit of information that makes sense to what we got. You can't have negative caps. You can't have negative shirts. It just doesn't make any sense. Okay? All right. We're going to flip it over here to part C. Let's go in here. There we go. Okay. Now we actually have an equation. This is kind of what you're used to seeing here. So, you've been given an equation. There's 2 of them here. X plus y equals 10. Negative 2x plus 2y equals 6. So up above, it's going to ask you to find 5 solution pairs to the equations below. You can include some negative values because here, remember, now we're not talking about a scenario, right? Now we're talking about just an equation. Okay? And then down below, if you look, you also have to find the x-intercept and the y-intercept. Again, just to help you out here, Remember, the x-intercept is when y is 0, and the y-intercept is when x is 0. Okay? So once you find your points in here, so x plus y equals 10. Come up with 5 combinations of x plus y equals 10. You're going to graph those and come up with the intercepts. Okay? So I want you to do those 2 questions. This may take us to the end of the hour, but we'll keep the video going. So we're going to pause the video. All right. So for x plus y equals 10, I just came up with some positive points because these would, if you go use negative numbers, you're very high up into the graph on the left side in quadrant 2, and we kind of lose some. So I had these points here, which I'm sure most of you had, or they could be backwards, and that's okay. So at 1, 9, that's right there. I'm a little bit off here. I'm going to pause this video and orientate this board here. Hold on. All right, let's see if that works now. So at 1, 9, it should be in the center. Close enough. Let's see, 5, 5, 6, 4. We're in the line here. 8, 2, and 3, 7. So when I draw my line here, and this is going to be different because I'm going to need a line with arrows because we're going to keep on going. All right, so let's connect through here. There we go. And for my intercepts, my x-intercept was at 10, 0 and 0, 10, which is right there and right there. All right, so that's what the first one looked like. Now on the second one, again, you had to point points going to give you a 6. So I did put some negative ones in here. And these happen to be the intercepts. So our intercepts were at negative 3, 0, which is right there, and 0, 3, which is right there. And at negative 2, 1, about right there, 2, 5, about right there, and 1, 4, right there. So again, when I do my line, I should line everything up here. And there we go. And that's what my second one looks like right there. All right, so moving on. Extend this page here because we need some room. So it says write an equivalent form of the equations where y is isolated on the left side. Well, if y is isolated on the left side, that means it's in this form, right? And we know that these are dealing with straight lines. So if I have x plus y equals 10, and I want y all by itself on the left side, I got to subtract x to both sides. And when I do that, I can get this. Or you can write it like this, because that's more in y equals mx plus b form, right? These are both the same equation, and these two are equivalent to this guy, right? We call this slope-intercept form, right? Y equals mx plus b. Well, when you see it as up here as an x plus y equals 10, we call that standard form. We're going to be learning more about that as we go on. But when x and y on the same side, we call that standard form. So it says confirm that the slope and the y-intercept are shown on the graph. Well, the slope is the number in front of the x, right, which is negative. So that's negative 1. And our y-intercept is the number, which is 0, 10, which is the exact same as it was up above. And if I take this one, negative 2x plus 2y equals 6, and I move the x's over, so I got to add 2x to both sides. Now I got the y on the left, but it's not just a y, it's a 2y. So I'm going to go through and divide everybody by 2. And here it is simplified as far down as it could go. Okay, y equals x plus 3. Okay, and then I know the slope is to be 1, because the number in front of the x is 1, and that was the slope up above, if you noticed. And my y-intercept is at 0, 3. So again, that's how I can take this equation, x plus y equals a number, and we call standard form, and convert it into either this one or this one in slope-intercept form. Okay. All right. So our last bit of business here is the summary. Okay. So it says, how is a solution of a two-variable equation different from a one-variable equation? Well, again, we mentioned this earlier. A one-variable equation has one solution. When you solve for x, you get x equals a number. Boom, we can check it. Correct. When you have a two-variable equation, you basically have an infinite number of solutions. And I can't spell, which is why I teach math. Infinite number of solutions. You create a line that goes on forever. And that's the difference between the two. Two variable solutions come in what we call ordered pairs. Okay? Ordered pairs. Remember, they're in the parentheses. X is first, followed by the y part. Those ordered pairs make up a point on a graph. Okay? There are infinite solutions to a two-variable equation. Again, that line goes on forever, giving you lots of combinations of endless possibilities. All right, the graph of a two-variable equation in the form ax plus by equals c will be this is a straight line. And it's also linear. The straight lines are linear. All right. And then last but not least, the intercepts will show you values which make the x or y 0. Okay. And again, if you have the x-intercept, you have the x point followed by a 0, y is 0. And if you have the y-intercept, x is 0. Okay? Those are the lines that fall on the x or the y axis. So I hope you found this video very helpful. And the homework for this is page 13, number 2. And on page 17, only number 35, only do A and B. So again, hope you found this video helpful. And this video is concluded.